Let's define a function. A function is a relation in which for each distinct value component of the ordered pairs, there is exactly one value of the second component. Okay, note that the word function actually refers to we have the distinct value of the first component. So the first component refers to your x, and the second component here refers to your y. Remember, when you're having the rectangular coordinate system, the vertical axis would be the y-axis and the horizontal axis would be the x-axis. Okay, let's have an example. You have f here, and then you have set of ordered pairs 1, 2, -2, 3, and then you have 2, 4. Now you'll be asked if this set of ordered pairs, which is what we call relation, so that's the term used for set of ordered pairs. We have 3 here, so we have 1, 2, -2, 3, and 2, 4. So is it a function or not a function? Okay, the answer is a function. Okay, why is it it's a function? It says here the definition. Function is a relation in which for each distinct value of the first component. So it means the first component, this is your x here, and this is your y in the ordered pair. So whatever the value for x, let's say 1, you have a distinct value of 2. So there's no other one for the other ordered pairs. So if there is, and you have a different value, then that is not a function. So in this case, you have a unique value for your x, -2, and you have a unique value for your y. So whatever your x here, you should have a unique value or just one value for your y. So that's define a function. Okay, so let's try another example. Okay, so in this set, you have 4 ordered pairs. You have 1, 1, 1, 2, 2, 3, 1, 5. So if you follow again the definition of what is a function, you need to have one distinct value for the first component, which is the x, and there's exactly one value for the second component. So looking at your x value here, this is our x here, our x, and x. Note that there is a value for y here. So y here, it's 1, and the value for x here is 1, but there is another value which is different from 1. It's a 2. And similarly, on the other side, you have a value for x here, and you have y is equal to 5. So in this case, this is not a function. Okay, so if you have an equation, let's say um, y is equal to 2x plus 3, then the graph here, remember this 2 here is your slope, and this is the y-intercept, which is your b. So the graph here is increasing because it's actually a positive 2 for your slope. So therefore, looking at this graph, this corresponds to a function. Because whatever value for x here, you have an exactly one value for your y, which is the second component. So another way to actually work with this function, or not a function, is just apply the vertical line test. So that would be easy. A vertical line test. So if I'm going to just apply the vertical line test, I'll just put a vertical line and I have only one intersection. That means that's a function. Okay. And try another example. Um, what if you're given with parabola? Parabola has an equation of y is equal to x squared right there. So if I apply the vertical line test, you have only one intersection, so therefore this is a function. So that's a function. What if the parabola is actually on the side or facing to the right side? When I apply a vertical line test, then you have two intersection points. So this is not a function. Because in this case, you have actually um, given a value for x, but you have different values for your y for these 2 points. Another example would be a circle. So when you have a circle and you apply the vertical line test, you will get actually 2 intersection points. So this one is also not a function. Okay. The function notation refers to, like this one here, y. We can change that into f of x is equal to x squared. What do you mean by f of x? That is the function notation. So we know that is a function, so we change y into f of x. So whatever your f of x, that would be your y. Okay. evaluating. So if you want to evaluate a function, let's say your function f of x is equal to 2x plus 1, and you're asked to evaluate what is f of 2. What you can do is just plugging in the value of 2. 2 here actually is your x. So this is your x value. So just plug it into the equation. So you will get is equal to 2 times 2 plus 1 equals. So what is 2 times 2 is 4 plus 1 is 5. So that would be our answer there. So when you evaluate a function. Okay. So again, the function notation f of x and evaluating it whatever value x. So what if your x has arbitrary variable like let me clear this up. Let's say you're going to have uh, f of x here is equal to 2x plus 3, and then you'll be asked what is f of a. So instead of a number, you're using a letter to represent the value for x. So same thing when you're working with numbers, what you can do here is just doing like what is f of a, you're just plugging in the value for a to x, so 2 times your a plus 3, and a doesn't have any value, so what is f of a would mean 2a plus 3. You cannot combine 2a to 3, so you cannot add those unlike terms, so that would be your answer. So that's how you work with functions. Okay, next we have to know the word domain and range. So I'll give you a chance to read the definition for domain and range. Okay, so when you're working with domain, remember this is refers to your x value. When you're working with range, refers to the y value. So now let's have an example. You're given with set of ordered pairs. What's the domain? So domain here, we're just listing all the values for x. So you're looking at domain, you're looking at 3, 2, and -1. So you just put that in solution set and write 3, comma 2, comma -1. Or you can put this in order, so it doesn't matter. And then when you say range, it refers to the y coordinates for the ordered pairs. So we're looking at -1, -4, and 5. So that would be 1, -4, and 5. So that would be the range. Again, domain refers to your x value. So domain would mean x, range would mean y. Okay. How about if you're given with a graph and you'll be asked to find the domain? So let's try that one. Okay, so let's say you're given with a line like this. And we know this one is a function because when you actually put the vertical line test, you have only one intersection. So now you might be asked what would be the domain. Now our answers here for the domain, it's the x uh, values for this line. And remember, this is a continuous line. So it means that in a rectangular coordinate system, if I have to draw that rectangular coordinate system again, this is our y axis and this is our x here. Now, going to the right, the highest value for the positive values for x would be positive infinity. And going to the left, it's negative infinity. So our answer actually for the x, because the line actually is occupying all the x values here, so that would be all real numbers for the domain. You can express this into set interval notation. So in set interval notation, you will say negative infinity going to infinity. So it means that the interval from the smallest value, negative infinity, going to the positive infinity, that would be your domain for this graph. So range would be looking at your y. So your y-axis, if you're looking at your y-axis, the graph actually occupies all those y values. So it means that I'll mark the values negative infinity to the smallest for y at the bottom and positive infinity on the other side. So our answer is just the same as the domain. That would be negative infinity to infinity. So that would be our answer. Okay. So that's how you're finding the domain for the line there. Okay. So what if you're given with another example, like uh, you have y here and then you have your x here, and then the line is just a horizontal line passing through, let's say, value of 2. So you'll be asked again what would be the domain. So domain, if you're looking at this graph, it occupies the values, all values for the x-axis. So that would be negative infinity, the smallest, and the highest is positive infinity. So our answer here would be all real numbers for the x-axis, and in set interval notation, that would be negative infinity going to infinity. But watch out with the range. When you have range here, you're looking at only one point. It's just a point because the line occupies only a single point for y. Remember, our range is refers to y values. So you have only one y value for range, and that would be 2. So that's how you write that out. Next example. What if you're given with a parabola? So let's say parabola right there. When you apply the vertical line test, you have only one intersection. So this is a function. So if you're asked to find the domain and range for this parabola, so domain would be uh, all real numbers. So let's say I have here my x-axis and I have here my y-axis. So the vertex actually is at point of origin, which is 0, comma 0. So the domain would be negative infinity going to infinity because it occupies all values for x. Because if you're going to look at the movement of the parabola, this parabola actually is continuous and it's moving going to the right, and on the left side it's moving to the left. So it will occupy the smallest value, or it can reach to the smallest value, and it can reach also to the highest value, which is positive infinity. For the range, um, you have the smallest value for your y here, it's 0. So since that's part of the graph, so it's over here, I'll mark a different color. So that's the smallest value there, which is the vertex. So you use bracket because that's part of the graph, 0, comma, and then it goes up. The parabola is pointing upward, so it reaches positive infinity. Again, it's pointing upward, the parabola, so it reaches positive infinity, and that would be our range. Okay, so let's erase that one. Now, think about if you have a line that is going up right there, the one that we did a while ago. Uh, this is increasing. So this is similar to if you're working with charts. If it's going up, the slope is positive. So the slope here is positive of the line. It's increasing. If the line is going down, the slope is negative. So that would be the decreasing. Okay, interval of your function. So those two lines are functions. So if the line is a horizontal line, that is still a function. Because if you put the vertical line test, that's a function. So I'll actually show that to you. You have one intersection here, that's a function. One intersection here, and also here. So that is still a function. And we call this a constant for the horizontal because it doesn't change. Okay, so that's the three actually kinds of interval for functions. So increasing, decreasing, and constant. And I'm going to emphasize again the symbols when you're going to have something like this in your graph. So if you have a point that is not included, you have to have an empty circle. A point that is shaded, the point is included as part of the graph. Okay, so those are the two symbols that we use for the graph. So this is similar to what we had in the previous section for the less than, uh, greater than. That's the empty circle. The less than and equal to is the closed circle. Same with the greater than or equal to. So it's just the same symbol that we're using. Okay.